as we look at this on 43, it says, and I know that this didn't copy well, so I apologize. It says we can use the tangent line to approximate function values when we have limited info about this cute little curve. So something to think about. And if I were you, I might draw in that curve because I know it didn't come out nicely. We just have this nice little curve. And then we have this nice little tangent line. And the point of linearization is to say, okay, I've got a very simple tangent line. And if I were to find the y value on my tangent line, say at this x coordinate, then its y value is going to be pretty close to the y value on my function. It's just going to be a little bit bigger or a little bit smaller, and that's no bigs. We can handle it. It'll just give us a nice approximation. So let's see what AP is talking about. Well, real fast. It says, given a point on a curve, so if I use this point up here, where they had that point of tangency, and I called that A, f of A, x comma y, right? And it says, and the derivative is f prime. We can write the equation of a tangent line. AP is always going to ask you what the equation of that tangent line is, and you guys, that's just that point slope form. Y minus y equals my slope, I'm going to call that f prime of A, times x minus x, and my x in this case is A. So they're always going to want you to write the equation of that tangent line, and then they said, go ahead and use that tangent line to approximate when x is another x value pretty close to that point of tangency. Let me just explain these, and honestly, if I were you, I don't even know if I'd draw these in. I know they didn't copy well. Let me just explain to you what I was trying to convey here. We've got this red function, and the point of tangency is the black point of tangency, right? Black point of tangency right here. And would you say that the y value on this tangent line here is going to be pretty close to the y value on the actual function? I'd say it's going to be pretty close. And this is me just zooming in again. Here's my point of tangency. Are these y values going to be pretty close? Yeah. And then again, I just zoomed in again. Here's the point of tangency. You're saying, oh, could I estimate the y value of this function using that tangent line? Yeah, they're going to be pretty close. So again, is redrawing those worth it? I wouldn't worry about it. Okay, so now let's put this into motion. It says, for the differentiable function f of x, all we know about the function is it has this point and that slope when x is 2. That's all we know about it. Use the tangent line to approximate when x is 2.1. So you guys, AP is going to give us 2 points for this problem. They said use the tangent line. So one, let's go write the equation of that tangent line using point slope form. Y minus y equals my slope times x minus x. What do we think? Y minus 7 equals my slope of -3 times x minus 2. That's it. You guys, is that the same as -3 times x minus 2 plus 7? Are those the same? Yeah, I just moved my 7 over, right? Because when they say use that tangent line to approximate when x is 2.1, we just have to have my y by itself. So we could say, all right, I know the estimation then is going to be, we're going to say y is going to be about, if you write an equal sign, AP is fine with it, but it's going to be about, and we're going to just use this exact tangent line and just plug in when x is 2.1. So we had -3 times 2.1 minus 2 plus 7. Let's practice some mental math. Mental math. 2.1 minus 1. 0.1 times -3. -0.3 plus 7. 6.7. And they're saying when x was 2, my y was 7. When x is 2.1, my y is 6.7. That's going to be pretty-ish close to what the actual y value of the function is. Again, do I wish that we had more real-world application of this? I sure do, but I think it's too complicated for where we are in calc. So, oh, this is a free response. Guess what? Free response, you end right here. We don't have to take that any further. You know what you do have to do, though? You can't leave the 7. You can't leave the y with something else. Just move that 7 on over, throw that 2.1 in, and we're done. Cool. Free response. Let's practice it. Write the equation of a tangent line when x is 4. Let's just start with that. Write the equation of a tangent line. So let's do a little y minus y. Y minus what when x is 4? Do we have info in that picture? Yeah. So it'd be y plus 5 equals, what's my slope when x is 4? 6. X minus 4. Done. That's the equation of the tangent line. They said, hey, use that equation of the tangent line to approximate not when x is 4, because that's what we use to write the equation of the tangent line, but when x is 3.8. So all we have to do is go plug in a 3.8 right there. I'm going to go move my 5 at the same time. I'm going to say 6 times 3.8 minus 4 minus 5. Done. So let's do 2008, then 2017. So 2008 says, hey, the function, they gave us this point. F of 2 is 1. They said F prime of 2 is 4. They said F double prime of 2 is 3. What is the value of the approximation when x is 1.9? You guys, is 1.9 pretty close to 2? Yeah, look at this. Using the tangent line. You guys, first we got to go write an equation of a tangent line. Y minus 1 equals my slope when x is 2. 4 times x minus 2. Beautiful. You guys, they just put that in there to be ornery. We didn't even need that. Rude AP. So, you guys, boom, that's the equation of the tangent line. They said use that to go approximate when x is 1.9. All we're going to do is we're going to go like this. Boop, go throw in 1.9. And I'm going to move my 1 over at the same time. 1.9 minus 2, and then add a 1 over. This one, unfortunately, we got to get an answer. What's 1.9 minus 2? Yeah, thanks, buddy. So I got 4 times negative 0.1 plus 1. So negative 0.4 plus 1? B, 0.6. You got it. We can do that. We can do this. Let's just do one more. And then, you know what, guys? We're done. Okay, 2017, a little bit more recent. Whew. F is this function. Here's F. What is the approximation when x is 1.5 used by using the tangent line when x is pi over 2? You guys, we need a tangent line when x is pi over 2. To write the equation of a tangent line, I need a point and a slope. My point would be pi over 2 what? I don't know. That's going to be my point. Can I go find my point? When x is pi over 2, how am I going to find the point? Plug it in, boop. I'm going to go find f of pi over 2. I'd have 2 times the cosine of pi over 2 plus 1. Alec is sad that we've got to use the unit circle right now, and I bet he's watching this and saying, oh, crap. Unit circle, cosine at pi over 2. Yeah, boom, pi over 2 is up here. X value is 0. 2 times 0, 0 plus 1. My point is pi over 2, 1. We got my point. Let's go get my slope. Here's f. The slope would be f prime. F prime of x. Derivative of 2 cosine. Yes, sir. Of x plus the derivative of 1. We don't care. F prime of pi over 2. We need that slope when x is pi over 2. Sine at pi over 2. Yeah, the sine is going to be 1. 1 times that negative 2 is going to get me negative 2. So you guys, you just found your point, and we just found our slope. This is like a lot. They typically put these as free response questions, not a multiple choice, because this is a lot for a multiple choice. My slope is negative 2. Can we go write a point slope form with this point and that slope? Sure. Y minus 1 equals my slope of negative 2. I feel like y'all are so quiet without Mateo and Landon. Y'all are being so quiet. X minus. Thank you, Teddy. Okay, there's my equation of my tangent line. They said, estimate when x is 1.5 using the equation of the tangent line. We got the equation of the tangent line. Now we got to go plug in my 1.5. Boop. So my estimation is going to be negative 2 times 1.5 minus pi over 2, and I'm going to add my 1 over. And unfortunately, this is a multiple choice, so we got to get it. We got to get it. Can we distribute out that negative 2? They're no dummies. They did this on purpose. Negative 2 times 1.5. Negative 3. What about this hog? Say it again. Yeah, plus pi, because my negative times a negative cancel out. Same with my 2 times my over 2. And then plus a 1. Final answer. Yeah.